So we are trying to understand the growth of Fibonacci, right? And we want to say that Fn, this Fibonacci is like, this is at least 1.5 times Fn minus. That seems to be the claim. Is it correct? And then how do you prove this?
We can start by dividing successive terms in the sequence, right? To see the ratio.
Yes, and that seems to be, that's what maybe, that's what Ishana did to say that this seems to be true. But yeah, we can also do it. What is it? 8 and 13 and then 21. So you take the ratios. First two terms don't have sort of anyway. So 5 by 3, is it? What is, how much is 5 by 3? It's more than 1.5, right? 1.66 something.
Yeah, about like 1.6 repeating.
Right. And this 8 by this thing?
That's 1.6 exact.
Yeah. And then similarly, yeah, so it may not be exactly like what we are thinking. I don't know, to check.
Yeah, that's also 1.6.
Okay, more than 1.6 at least. Yeah. And then this also, I believe, is more than 1.6 and so on. So it seems to be true. But how do you prove it? That is an interesting thing. So even if you can show it's, at least 1.5, then also it's good enough. Right? So I don't know, but this is Fn is equal to this plus Fn minus 2. Yeah. Well, I think you can just show that. I mean, if you can just show me that, this is one thing I'm thinking, you can do it in many ways. Okay, maybe if you can just show that Fn minus 2 is at least half of Fn minus 1, then also I'm happy. Right? Fn minus 2 is at least half of Fn minus 1. This is the other way. Okay, then also it is fine. Right, then you can apply this and get 3 by 2. Right? So can you show this, that the next term is not more than double the previous term? Yeah, so it's like opposite kind of thing, a control. See, that also we need, right? In order to show the growth, we need to show the control also in some sense. Otherwise, if Fn minus 2 is too less, then it won't support Fn to grow. So can you show that it doesn't double? That's what we said in the beginning, that it does not double, right? We said that in the beginning, right? So Fn minus 1 does not double Fn minus 2. It's less than the double. So this is easily always true. Right? Like if you look at this term, it cannot be double of this because it is this plus something smaller. That's the nature of the sequence, right? So it is true that it won't double. Sorry?
You just substitute in the first line, right? Fn equal to Fn minus 1 plus Fn minus 2, then subtract 1 from the right hand side.
Subtract 1 from the right hand side.
No, the claim in claim that equation, in that statement, you just subtract.
This one, okay.
Yeah. So in place of fn, you can write fn minus 1
Okay.
plus fn minus 2 greater than 1.5.
Is no, but that's the claim. Yeah, and so basically proving that claim boils down to this. That's what you're saying, or this, and then this basically, this basically boils down to the n minus, but maybe, yeah. So basically it boils down to proving this, right? Because you can cancel this, right? Boils down to proving that I don't know what happened here. Oh, this is n minus 1. That it is bigger than half of the previous. It's lesser than double of the previous term. So, and that is a trivial thing. That's obviously true. And so we are done. Okay. You can do it in many ways. So think about this. Yeah. If this argument is so far is so, maybe so that we are given sort of two arguments, so don't confuse. Is my argument, first argument, clear? Is this argument okay? I mean, later on you can think of more argument, that's a different thing, but is this argument understand? Are you understanding the argument? Okay. That the previous two terms we are using, and the n minus 2th term is not less than half of fn minus 2. So it's bigger than half of fn minus, bigger than half of fn minus 1, and then we are done. Okay. So you can use other things, but then the homework is, but so far what we have done is not shown the 1.6 business. So homework is to prove that fn is at least 1.6 of fn minus 1. Okay. And the next homework, which is almost trivial now, is to now use this to show that there is no polynomial. Okay. Just like 2 to the n, this will sort of become 1.5 to the n. And 1.5 to the n also has the same kind of things. Think about it. Complete that. Yeah. We will discuss it next time. So these are the things. Okay. Next time we will maybe show a little bit more about Fibonacci sequences, which we were doing in the recurrence class. We took a different approach, but now we will take a slightly different approach, and we will prove the same thing. Okay. Because also it's all about polynomials. That's the application of polynomials basically. Okay. But yeah, we will just show it in a different way. Yeah. So this is mostly about the growth of polynomials that we are doing. Okay. Yeah. So maybe I have things to say, but I'll stop here today. Okay. There are many things, more things about